Hey, welcome back. This is part four of my review for Fraser Valley Climate Action of Nat Bullard's really excellent presentation on the state of decarbonization in 2025. So we left off part three on a good note, noticing that off-grid PV or solar has grown to almost 6 gigawatts, but that only represents about 0.4% of all PV. So basically, the off-grid stuff that you think of it's it's a rounding error. It's fabulous to see this much on grid. Small grids, high penetration. Solar is more than 10% of 2021 power generation levels in 8 sub-Saharan African countries. So we could see some changes here. So as of 2022 generation, we get 43% for the first one, 20, 13, 11. So I'm thinking that 2021 must be left over from a previous year's content, but this is January 2025, as you see in the bottom corner, and there's some numbers from 2024, so this makes sense. And how much are these small grids producing in gigawatt hours? Okay, so a little bit smaller, um, but definitely solar's making some inroads there. So this is great because the cost of setting up solar power is so much lower than the oil and gas infrastructure you'd need for those options, or the coal burning infrastructure, and then the constant shipping. And if these countries are in some degree of turmoil, if your coal trucks get intercepted by armed rebels or something like that, then you're not going to get electricity today. But solar, dude, the sun just shines everywhere. So I kind of love what that's doing. It seems really good to me. um, Volume up, cost down. The levelized cost of wind and solar power is flattened, but is still declining. And this is an amazing story. Many people think solar is expensive. It is not. Um, so look on the right at the cost per kilowatt hour, right? So going down, the top of the graph is 60. Okay, red line. Follow the red line. Down to 20 cents, 10 cents, 5 cents a kilowatt hour. This is getting affordable. Um, and on the left, you can see wind has been following like a slower trajectory. Not sure if the scale is the same for both of these, but maybe it is. And then the capacity, that's the bars, the colored part. You can see the wind it looks almost linear, right? And then you could see the bars for solar, the capacity installed is growing. So as the cost drops lower and lower, it makes more and more sense, or it makes sense in more and more situations where people are like, well, solar makes sense in this situation. We won't go with gas or oil for more generation. So this is good. Greater size, greater scale. Onshore wind turbines have 200 times the rated output of turbines in 1980. Yeah, I was down in Palm Springs talking to someone giving a tour of a wind farm down there. And what he said was basically, we're not putting up new towers. We're just taking down the old turbines and putting up new turbines that are more efficient. So that was interesting to hear. They got solar and wind down there. Onshore wind turbine output in megawatts. So one turbine is able to put out 10 megawatts um, in 2023. The rotor diameter in meters. This is crazy. They used to be quite small, and then they got to 50 meters or 150 feet in 1990. And when we get to 2015, we have some rotors that are 200 meters or 600 feet in diameter. We're approaching 250. One tower, one transmission, one electrical wire, but you're capturing a greater area. You're able to capture more power. Makes sense. So they're getting bigger. That might suggest that they're less affordable for individuals or for small cooperatives. That could be a downside, but things are going along. Increasingly affordable, the median income of US residential solar households continues to decline. So households that have solar, their median income is declining. It doesn't mean people are making less money. It means people with less income are able to have solar. And so that's pretty cool. Looking at the blue bars on the left, basically the middle of the road, people who had solar, the median, you would have been looking at like 140, 135,000 per year, and now people with like, looking at the right side, what is that number? Is that like 115,000? So people who earn $20,000 less per year are now in the middle of who has the solar. Of course, there's people with more money and there's people with less money in their income. Relative to owner-occupied households. Okay, I don't actually understand that one. Just going to move right along. Texas Sun. Texas will likely have more installed utility scale solar than wind next year. So I guess they've had a bunch of wind. It looks like they've had recently they've had 40 gigawatts of wind, but look at solar picking up. So let's go back to like 2010 when they basically had 10 gigawatts of wind and basically no solar, or 2015 when they had 15 gigawatts of wind and basically no solar, or 2020, the year the pandemic hit, when they had 30 gigawatts of wind and 5 gigawatts of solar, right? You're catching the trend here, right? And then 5 years later, the installed solar has passed wind, right? So the E is the estimate, right? So I guess this little bump is where the numbers really end, and they're predicting it will go up there. Notice the battery. This is important. This means that when the sun goes down, that solar power in the batteries is still available for the grid. It's starting to extend the number of hours in a day that solar can carry the whole grid. And of course, with enough batteries, it could carry it all day and all night. The sun shines everywhere every day. So yeah, so that's coming as the battery capacity comes in. Notice the battery capacity is ramping quite quickly. That's good news. But notice it's lagging behind solar. Yeah, okay, that's fine. Okay, sorry, I was really excited about that one. That was lots of details. A curtailed spring. The spring curtailment of wind and solar has more than tripled. Curtailment, that sounds like where you cut something off prematurely. I don't know what that is. Solar, wind. I don't know what that means. I'm now curious to go Google it. Maybe you'll join me and do the same. But look, solar and wind are bigger. Windy, sunny Poland. Oh, wow, that's pretty cool. Poland's monthly wind and solar generation now tops 30% in summer months. Well, that makes sense, as the Earth tilts and we get more sun in the summer than in the winter. Yeah, I think that makes sense. That's why it's warmer. So it looks like there was a lot of wind, and now solar is really making inroads. Fantastic. That's good. Markets respond to economics. We do know that. UK residential solar PV installations have been growing since 2020 without incentives. Okay, so look at the end of that chart. That's the part where the government isn't promoting it. Look at that growth. That's pretty good. I mean, November's a little lower. Who knows why? This is such an interesting concept. The European Union experienced more than 9,000 hours of negative power prices in 2020. That's where there's so much power available that they start paying you to use power, right? I just think the concept is hilarious. Maybe that's scary to people who've invested in um, infrastructure in order to produce electricity, but if they have overcapacity, that is generally a good thing. So, yeah. Okay. Same sun, less capture. Interesting. European solar capture rates are falling. The solar capture price relative to the average day ahead power price. Okay, I don't understand that, so I won't comment on it. If you're interested in any of the things I skipped, just hit pause and you can examine it yourself. Into the 100s, global battery energy storage capacity additions increased by 70%. That's good. So that's not just an increase, that's an acceleration of the rate of installation. So that's good. So in 2021, let's go 2020. We're seeing 11.8 gigawatt hours um, of installations in 2021, 2022. What is that? Double that. And then we're seeing 96 gigawatts in 23, 169. So that's pretty good. In 2024, looks like they didn't have complete numbers. That's why the E's on there. Stored energy by the gigawatt. California's installed battery energy storage capacity increased 22,000 times okay, in 15 years. So they're sitting around 13.4 as of October 2024. And they had some fires and they lost 2% of their capacity recently because the battery plant burned down. But hey, this is good. And I know the duck curve for electricity pricing in California, the shape is changing because this storage is stretching out again the number of hours that solar can carry things. So that's pretty good. We want to see those percentages increasing. There's still a lot of gas being burned down there in California to produce electricity. Stored energy by the hundred thousands. In 2010, California had 2 residential energy storage systems. It now has 193,000. Okay, so is this like power walls from Tesla, that kind of thing? I don't know. That's good. I mean, that many people won't be interrupted by a power outage or something like that. High temperatures, high availability. Okay, so these are American temperatures, Fahrenheit. So when it gets really cold, what does the availability do? You don't see a sudden drop or anything, right? And when it gets really hot, you don't see a sudden drop, do you? Well, maybe a little bit. But basically, look at that availability through that whole range of experience. The availability seems to be somewhere between 90 and 95. Seems low to me, but I'm from BC and maybe we have more reliable power. I'm curious about that. It just doesn't seem to go out very much. Wind and batteries and seasonality, Great Britain battery energy storage system revenue. So that's making money from it. Okay. And they seem to be tracking pretty closely. And wind generation. So I don't know, something happened around 2024, March, April, like it synced up. Do you see that? I don't know if that's because the battery capacity grew. I don't know. It just seems kind of like they're following each other. Hopefully they're profiting and doing well. Batteries dominate Texas regulation. Oh yeah, this is huge. It used to be you had to run a gas plant all the time just in case something bad happened. You could flip the big switch and stabilize the grid. But batteries are so fast. They provide all kinds of power conditioning. If they have to bring the frequency up or down to keep it where it's supposed to be, batteries are doing the job. And look at that, 100% share of ERCOT. This is Texas's regulator. Rig up, rig down, provided by energy storage resources. Look how that just grew from like 2021 to 2024. Basically, they just switched to batteries, it would seem. All right, that's good. Within 5 seconds to respond to changes in scheduled system frequency. I remember they had a gas plant go down, and it was like the batteries just kind of carried it. It's like, nice guys. Wind, solar, and SADI. I did look that up, but I do not remember that one. In the US, high wind and solar generation does not mean high electricity system disruption. Okay. So we have wind and solar generation as a percentage of the generation, left to right, and SADI. Oh, yeah, yeah. This is like hours of outage, basically. And so where you have the most wind in Iowa, you have very low hours of outage. Virginia has a very low number and a very high number of hours of outage. But that's just 2 data points, right? Look at Minnesota; they have very low and 30%. So it looks like increasing that percentage doesn't make the grid less reliable. Certainly, the premier of Alberta in Canada has been basically lying, saying that renewable energy like wind and solar are extremely unreliable, and for that reason, we need to like ban them and basically burn gas. As a gas producing province, that's not surprising, but don't lie to people. Vermont, dude, your reliability is pretty bad. Look at that. 16 hours? I don't know. Whoever's in the top half of this graph, get your act together.